Bismillahirrahmanirrahim. I am Muhammad Ehsan Chattha, Assistant Professor, Government Degree College, Chavatne. Dear student of the second year chemistry, today lecture is about ionization energy of the chapter number 1. First, we define the ionization energy. The ionization energy of an element is the minimum quantity of the energy which is required to remove most loosely bounded outermost electron in the valence shell is known as ionization energy. For example, as we remove the first electron from the sodium atom, the sodium atom first change to the from solid form to gases, then provide 496 kilojoule heat to the gaseous sodium atom to form the sodium gaseous positive ion with removing one electron. It is known as ionization energy I1, or sodium have only one valence electron. Its energy will be equal to 496 kilojoule that is required to remove the outermost electron in sodium. The element with greater number of the valence electron, as in magnesium, the first ionization energy is always lower than the higher second and higher ionization energy. Magnesium atom have total 12 electron in the valence shell, 12 electron in atom, 2 electron present in the valence shell of magnesium. When we provide 738 kilojoule energy to remove its outermost electron, then it form neutral gaseous magnesium to gaseous magnesium positive 1 ion with removing one electron. Similarly, if we provide more energy to remove the second electron from its valence shell, then we have to provide near about double of its energy. तो magnesium atom ions, when it gaseous ion taken, it pull the outermost electron closer toward the nucleus. Hence, more energy, second ionization energy is more energy is required to remove the second electron. Then the second ionization energy is higher than the first, so its value is 1451 kilojoule energy is required. So we learn about the number of valence electron from the ionization energy values. In sodium atom, the first ionization energy is 496 and second ionization energy is 1000 times higher. So it is ruled out that alkali metal have the second valence electron. Similarly, magnesium have the two valence electron. If we provide more energy to move the third electron, that is around the 7700 kilojoule energy, that is much more 10 times greater than the first energy. So it is the third electron is not present in the valence shell, so its the valence shell electron are equal to 2. It indicate from the ionization energy. Ionization energy is index the number of the valence electron. Variation within the group, the factor upon which ionization energy of the atom mainly depends are the magnitude of the nuclear charge, size of an atom, shielding effect. The definition of the shielding effect is as the shielding effect is actually the repulsion due to electron in between the nucleus and outermost shell. Again listen student. The shielding effect or screening effect, it is defined. It is actually the repulsion due to electron in between the nucleus and outermost shell. This effect increases as the size of atom increases in a, due to addition of extra shell down the group. So successive extra shell in every new period down the group as we move, the number of shell increases, hence the shielding factor also increases down the group, nuclear charge also increases, but due to the increase of the shell, the nuclear charge remain ineffective as we move from top to bottom. The main factor is the shielding factor, which have increased the size of the ions or the size of the positive ions. Here as consider as we move from top to bottom, as just is considered in first A group of the element, lithium, sodium, potassium, rubidium, cesium and francium. As we move from lithium towards down the group, its energy ionization energy is decreases due to increase in size, and easily we remove the electron by providing much lesser energy to the gaseous atoms. This is the trend down the group. In every group, increase in size, more shielding effect, not effective nuclear charge, no effective nuclear charge, we can easily remove the electron down the group with lesser energy. So the ionization energy decreases as we move down the group, as shown in the graph 1.3. Variation across the periods. Generally, smaller the atom with greater nuclear charge, more strongly the electrons are bounded to the nucleus, and hence higher the ionization energy of the atom. By moving from left to right in a period, the outermost shell remains the same, while the nuclear charge increases effectively. That make the removal of electron quite difficult. Hence, ionization energy increases as we move from left to right in period due to number of shell remain constant, shielding factor remain constant, and size of the atom is much reduced in size. So the more energy is required to remove the outermost electron. Hence ionization energy increases in every period, as in graph shown from hydrogen to helium. Ionization energy is increases 1400 to almost 24 kilojoule per mole. Similarly, in second period, lithium to neon, ionization energy increases. Similarly, in third period and so on, as in figure 1.4 shown, the electron is very difficult to remove from the element that is present on the right side, and so the ionization energy decreases as we move from left to right in period. So ionization energy in period increases, while in group ionization energy decreases. Dear student, this is all about the ionization energy and its variation in the period and group known as periodic trend. Thank you. Allah Hafiz. Take care.